ready with it, or recording need to be stopped, please.
Thank you so much, Dr. Firdaus. I hope Harvinda ma'am has joined the session as well.
Yes, ma'am.
Okay, great. Okay, so good evening, everyone, first of all, and hope you all are doing quite well. My name is Dr. Shivangi, and I am working as an assistant professor in IIM Business School, New Delhi. And I feel truly honored to welcome you all to day 3 of our 7-day online workshop on research methodology in econometrics. At the very outset, I would like to extend my heartfelt thanks to Dr. Firdaus Ahmed for entrusting me with the opportunity to serve as the moderator for this enriching academic journey. It's a privilege to be a part of this esteemed platform that brings together bright minds and curious learners from diverse backgrounds. Today's session marks the beginning of a deep dive into the world of research methodology and econometrics, which forms the backbone of evidence-based economic research. Our focus for the day is the introduction to research methodology and econometrics, a fundamental topic that lays the groundwork for understanding how economic theories translate into practical data-driven insight. Research methodology provides the roadmap for any academic or applied investigation. It answers the why, what, how, and when of the research process. Econometrics, on the other hand, equips us with quantitative tools and statistical models to analyze economic data and test hypotheses. With that, it gives me immense pleasure to introduce our esteemed speaker of today's session, Dr. Harwinder Kaur. Dr. Harwinder Kaur is an accomplished economist, researcher, and academician with specialization in international trade, econometrics, environmental economics, and economic growth. With a PhD and MPhil in economics from Lovely Professional University, she brings in depth academic knowledge coupled with applied expertise in time series and panel data analysis using advanced tools like EViews. She has several high-impact publications to her credit in renowned international journals such as InderScience, Sage, and Emerald. And she's also actively engages in mentoring young scholars and students in the art and science of economic research. Apart from her academic excellence, she contributes meaningfully to institutional activities as an event coordinator at Chandigarh University, promoting a vibrant culture of academic discourse through seminars, workshops, and student-led research initiatives. We are indeed privileged to have her with us today. Please join me in welcoming Dr. Harwinder Kaur for a session on Introduction to Research Methodology and Econometrics. So before you start, ma'am, I would like to request every participant to please keep your mics on the mute and let ma'am finish the session. Once the session is over, we can have a question and answer round. In case if you have any question in the meantime, you can just drop a message on the chat box and later on it will be answered definitely. Ma'am, the floor is all yours.
Thank you, Shivangi ma'am. Thank you so much for such a wonderful introduction. I hope I'll be able to deliver my best to them because it's a hands-on session, so they might ask question in between also. So I think that should be okay with us.
Yes, definitely, ma'am. Whatever suits you, we can go forward with that.
Thank you. Thank you so much. So welcome everyone. It's like it's definitely going to be a wonderful experience with all of you. I hope whatever I am going to teach you in this session, if you have any query in between, just put up a message that time only when you are doing especially the hands-on practice and ask me question at that time only. Before that, I'll just deliver a PPT on whatever we are going to do hands-on practice only. Okay. So I am just sharing the screen. Is this PPT visible to everyone?
Yes, ma'am.
Okay, so today we are going to talk about the classical linear regression function. You have been doing this exercise from last 2-3 days, that what is regression, what is the requirement of the regression, why do we need to conduct the regression. So there are some basic assumptions related to the regression function. Today we will be discussing those regression assumptions. Now the classical linear regression function, this is basically a statistical tool to analyze the relationship between two variables, one dependent and the other is the independent variable. And we usually do it with the help of the ordinary least square method, that is called the OLS method. That is how one variable is impacting the other variable we do with this kind of a function. Now, what are the components of the OLS function? What you need to have before you want to run any function, any kind of a regression function through the OLS? You should have one dependent variable to which you want to predict or to which you want to explain. And one is the independent variable to which you want to explain like how this variable is impacting the independent variable. Then linear relationship, this is something we will be discussing in detail. Linear relationship means how one variable is predicting the other variable. Then the method is the OLS. Then we have a classical assumptions related to that related to the linearity, normality, heteroscedasticity, autocorrelation, multicollinearity, or related to the error terms. Now, application, this is used to predict, to forecast, to understand the relationship. Now, assumptions. The first assumption is the linearity in the parameter. Now, what do you mean by linearity in the parameter? Suppose here I have explained a regression equation where I say that yi is a function of beta 0 plus beta 1 xi plus ui. Here beta 0 is a constant, beta 1 is slope, which will determine how y is behaving with the change of the x. What is the impact of the x on the I will be determined by the beta 1. That is the slope of that particular relationship. And ui is the error term. Sometimes we are not able to capture all the variables which are required to determine this relationship y and x. And all those unobserved variable, unobserved factor, they are captured in the error term. Suppose you are saying that, price of a particular property and area of a particular property are directly related to each other, but there can be another variable also which can determine the price of that particular property. That can be locality, that can be its design, it can be the convenient, how it is close to the other things, market or schools or hospital, where it is actually located. So there are so many factors which can impact the relationship between the price and the area of a particular property. But if you are not adding everything into your model, then also, and if you are not able to explain those variable, then also it will be captured by the error term. Now, the next one is the not. What if it is non-linear? How you can say whether it is a linear in parameter or not? Now, B1 is a parameter. I am saying I just want B1 to be linear. If x is in a square form, I don't have any problem, and then still the relationship will be relationship between both the variable will be linear. What does mean by non-linearity? When my beta is in a square form, when my beta is in a square form, then what will happen? There will be not a linear relationship. Either it will be a U-shaped kind of a relationship or inverted U-shaped kind of a relationship, that the impact of x on y will not be constant. It will be like whether increasing very fast or decreasing very fast. This will have a different kind of a relationship, not a straight line kind of relationship. As long as I say that linearity should be there, I say my relationship between x and variable is plotted in such a way that it forms a straight line. It can be upward sloping, it can be downward sloping straight line, it can be straight line also. So but the relationship between both the variables will be showing a straight line when you will draw a curve. Now if I say if you see this equation, you will see price is equal to beta 1 area square. Now here area beta 1 has a exponential, so this is a non-linear kind of a relationship. Now if you will see the graph also, this is a linear and this is a non-linear kind of a relationship. You can pretty, when you draw your graph of any particular variable, you can check whether it is a non-linear kind of a relationship or kind of a non-linear kind of a relationship. Now, random sampling, why it is required? Whenever you are working on a sample, if you are not choosing it independently, if you are not choosing it randomly, it will create a biasness. There, we will not be able to say that our estimates are best linear and unbiased estimates. So the sample should be very much random. Zero conditional means, now conditional mean this property is related to the error term only. The error term is uncorrelated with the independent variables. No omitted variables means the error of xi, the value of the xi is not impacting the ui. That is covariance between each independent variable xj, and the error term is 0. Means there is no relationship between the error term and the independent variable. Now, what happen if it is there? Now, suppose if you say that, if you say that, one second. Now, what you say? Let's say you are estimating salary and experience, but you omit an important variables like education, which is salary, which is positively related with the experience. So it will also affect the salary. If education is hidden inside the error term, then it is correlated. So that is like error term must not be related with your xi variable. Now the next one is the homoscedasticity. We call it heteroscedasticity also, and we call it homoscedasticity also. We deal with the problem of the heteroscedasticity. If it is a homoscedasticity, then there is no problem in the model. And if it is a heteroscedastic, then we have to find a solution for that particular problem to find a relationship or to find an impact of one variable on the other variable. Now, what is homoscedasticity? Refers to assumption that variance of the error term in a regression model is constant across all level of the independent variable. When your independent variable value is changing, if your error term is also changing, then there is a problem of the heteroscedasticity. If this is not the case, then it is a problem of then there is a homoscedasticity. Now, this is the graph. When you draw a graph to determine in your data whether there is a problem of homoscedasticity or there is a problem of the heteroscedasticity, you'll see your scatter will be along a straight line curve only, along your relationship only. Whatever you are predicting between x and y will have a straight line, and all the dots will be around that straight line only, most of the line. But in case there is a heteroscedasticity, the graph is more scattered, the plot is more scattered. So there is a problem of the heteroscedasticity. Now, how can you say, like, if we say to understand it more in a better way, we are taking a real life example. When we want to predict the electricity bill based on the house, homoscedastic means if the error, you are assuming that your bill is, suppose 1,000 per month for every house, and you have taken sample for the small houses only. So that bill can be 500 plus or 500 minus, less 500 or more 500 than the amount you are assuming for all the houses. So that is okay. This is called homoscedastic. Now, heteroscedasticity, if for the small house, the error is 200 and for the larger house, the error is 2000, then this is a heteroscedasticity. And like which is true also, if the size of the house increase, the electricity bill will also increase. But we are assuming when we are running any regression that if the x value when changing, your error term is not changing. If it is changing, then there is a problem of the heteroscedasticity. Then their OLS, this OLS results will not be appropriate because your results will be violated then. Next is now how you detect the heteroscedasticity through the residual plot. We'll do hands on this. We have a BP test also. We have a Y test also. Now, how to what are the remedies for this also? We use the robust standard error, transform the variable, or either apply the weighted least square method. Now, the next property is the no autocorrelation, which is also called the serial autocorrelation. Now, in regression analysis, autocorrelation occur when the residuals are not independent of the each other. The error term in the one period is correlated with the error term in the another other period. Now, if you when we are modeling unemployment rates as a function of GDP and inflation, if unemployment rate is influenced by the rate in the previous year, residuals will show the autocorrelation. Whenever we are working on such variables whose value is predicted with the past value also, or whose value is related to its past value, then there will be a problem of the autocorrelation. You'll see this will mostly happen in case of GDP data, in case of the stock market data, such kind of a data, there will be a problem of the autocorrelation. There will we have to find a solution for that. How we can find a solution for that? We'll have to add a lagged variable for that. We will have to add lags for that particular variable when we want to study that variable in our model. Okay. Now, how you can study the autocorrelation? You'll see if the original function is yt is equal to beta 0 plus beta 1 xt plus ut. If the error term is there, then obviously this ut is not there. The error is also there, which is the t minus 1 in determining the. Now, why yt minus 1? Because whatever error is there, whatever autocorrelation is there in this variable x will lead to the problem of determining the y also. So that's why we here say that this p is the autocorrelation, ut minus 1, that is the error related with this term impacting the yt. Okay. Now, again, this model will again become where we have to include the value of the error term also. Like monthly electricity bills are autocorrelated. Your first bill is, somewhere similar to the previous bill, and that is somewhere similar to the previous bill until and unless you increase your consumption or you install something new in your house. So that is the example of the autocorrelation. This is highly there in the stock market data. Now, how you detect the autocorrelation? Residual plot. We can we can draw a graph on your data set, and we can draw the plot for the residual term, error term, and from there only we can check whether error is there or not. Again, we have a DW test, that is like to determine whether autocorrelation is there or not. There is a specific value of the DW. If your AR falls in that particular category, there is no problem of the autocorrelation. Then we have a BP test also. Then we have another test also, run test also. Now, remedies, usually we opt for is the add lag dependent variable. Now, we add the one lag value of the dependent variable. Whatever is the dependent variable, we will use the lagged value of that dependent variable as an independent variable in the model, and then we run the model. So that's why we have ARDL for ARDL kind of a model for that specification. Then we have a GLS model also. But for this, you have to make sure the OLS properties are totally violated, then only we use the GLS. There is a, very much, these are the very much specified kind of models. So avoid using the GLS. The ARDL is good model to go. Then multicollinearity. Now, what is multicollinearity? When one variable, one independent variable is a combination of the two other independent variable in your model, then there is a problem of the multicollinearity. The independent variable should not be perfectly linearly related to each other. This means that one independent variable cannot be perfectly predicted from a linear combination of the other independent variables. Then there are no exact linear relationship among the independent variable. Suppose you have added annual income to determine the relationship between, we have a regression equation where annual income is one of your independent variable. Now, you are adding monthly income also into your model, and you are adding annual income also into your model. There will be a problem of the multicollinearity because annual income is nothing else but the 12 times of your monthly income. So there will be a perfect multicollinearity. So that's why we say whenever you are framing any regression equation or whenever you are trying to predict one variable with the help of the other variable, you should have a strong theoretical background to add those variables. And if it is not so, you will face the problem of the multicollinearity. Okay. So this is the example. Suppose you have a x3 as a variable in your model, and x3 is a combination of two variables, other independent variables, that is the x1 and x2. And we have assigned a lambda that is the constant value to the x1, and 2 is the constant value given to the x2. If you will calculate it, the exact function should be equal to 0. If it is not equal to 0, then there is a problem of the multicollinearity. It should be in a way that it is equal to 0. If lambdas are not equal to 0, then there is a problem of the multicollinearity. Then normality of the error terms. Your error term must be normally distributed. So these are the major assumptions of the OLS which we will be studying on. Now we'll do some hands-on practice for first three things, that is the multicollinearity, heteroscedasticity, and autocorrelation. So I request all the students if they can start with their EViews. Shivangi ma'am, can we unmute any one of the student to know like whether they are able to do it or not?
Yeah, sure, ma'am. I can request dear participants, all of you. I hope you guys are able to do what ma'am is guiding. And if anyone is having issue, please you can unmute your mic and just let us know so that it will be easy for ma'am also to explain.
Ma'am, right now only the presentation screen is visible.
Okay, I'll start with the EViews. I'll open up EViews. It's already there. No? So I hope you're able to see the EViews now.
Yes, ma'am.
Okay. Okay, so everybody have similar screen?
Yes, ma'am.
Okay. Okay, so first of all, we'll import the data set. Now, just understand, we work, especially on EViews, we work on three different kind of a data set. That is the, time series data set. Then we have a cross-section data set, and then we have a panel data set. When you import file for a panel data, there is a different setup for that. When you import data for time series and cross-section, there is a different kind of a setup required for that. Now, today we are working on the data set, that is the time series data set. So I hope all of you have data also with you.
Yes, ma'am. We have the data.
Okay, so just do it with me. You have to go to file. We are just now trying to import the data set. Okay. Any of you will respond with me, please. Okay, so that I am able to understand you are able to do it or not.
Dear all participants, please respond so that we can move further.
Yes, ma'am, sure.
Okay, so we'll go to file. We'll go to import. We'll go to import from files. So now wherever you have saved your file, just click on that, open the file, and something like this will be there. Okay, exactly like this will be there. As we have only one sheet in that Excel sheet, so this is not a problem. You need not to change it. Okay, then go to next, go to next, then next, and then finish. Okay, so can you see this now?
Yes, ma'am, visible.
Okay, okay. Now, you see, you can change the name of each variable. You just click on any particular variable except C, except residual, except year. You can work on any particular variable. Now, export is one series with us. Just click on the, double click on the export, and you'll see the data for export is there. There?
Yes, ma'am.
Yes, ma'am. Okay, so you will just, if you want to change the name, you can change the name because that will be easy when you are running any regression function. So you can just click on the name and give only export. Just mention only export and then click on OK. And then Close it.
Harwinder ma'am, just one clarification. Was the data set
Hanji.
shared with us, or this is some data set, random data set of our own?
No, ma'am, I have shared it with you, the same data set I'm working on.
It has been shared in the chat box.
Case
Please
study?
do it. It's
No.
not case study. It's a data set shared with all of you in the chat box only.
Share again, madam.
Okay, Shivangi ma'am, please, can we share the data set again with them?
Yeah, sure, ma'am. If it's there, I'll just copy and paste again.
Okay.
I
no
have
problem.
done it again for you.
Okay, thank you so
So that
much.
is why I am requesting you all to join, on time. So please go ahead.
Yes, please do it quickly because all the properties will be tested on this data set only. Then you will not be able to understand the results and output. By the time all of the students, they can change the name of the variables, just simplify them. Okay, you can do the same thing in your Excel sheet only, where we have already imported the sheet, so you can do it here. It'll be easy to run the analysis then.
So Harwinder ma'am, I'm getting a response link, imported series and alpha objects to external source. Should I do yes or no in that?
Yes, yes.
Yes.
Yes, ma'am, done.
Okay, so now we have the variables with us. You can say the range in the sample is similar. We have 25 observations. We have a data set for 25 years and everything is correct. If you see something different here and something different in your Excel sheet, you have to again recheck it. That is there any error or not? If there is an error, just correct it and then upload your Excel sheet again. So that's why whenever you're working on your data set, make sure your Excel sheet is correct and then only you upload it on the EViews. Now, we are trying to do the first assumption, that is the assumption of the heteroscedasticity. Now, this command box is given where you can mention your null hypothesis when you test your heteroscedasticity. So you just click here and then mention null hypothesis. That is there is no heteroscedasticity in the model. There is no heteroscedasticity in the model. Then you can assume the other one, there is heteroscedasticity in the model. Whatever you are doing, if you want to keep a record of that, you can just type here like whatever you want to type here. Now, the first thing is we are trying to estimate it now. Just there are 2-3 ways to do this. That we can do it from here also, quick and then estimate series, or we will do it directly from here only. Whichever is your dependent variable, just click that dependent variable first, press Control and all the other independent variables. And then open as equation. And then we have various methods to run the analysis, like OLS. LS is the OLS method. We have GMM also. We have ARCH method. We have, this ARDL also. There are a number of methods you can do, but we are doing OLS method only. You can check the sample is there from 2000 to 2024. And here we have various options. Like the first one is the ordinary. We'll keep it like that. We have various options. That hack option is also there. If your data is facing any specific problem related to autocorrelation, then we apply that particular technique. We'll discuss it later. Just keep it ordinary. Keep the specification like this and then click on OK. And then click on OK. Is it okay up to this?
Yes,
Could you
ma'am.
please repeat this process once again?
Okay. I'll do it again. GDP. Then I'll be clicking on import. Then I have inflation. And then I have unemployment. Okay. I'm leaving export. Open as equation. Then click on OK. This is the output. This is the regression output we are getting. Now, how you will be interpreting these? I'll be sharing one more screen with you. Now, these are the output. You can copy and paste in a separate Word file. You can copy these outputs. How you have to do it? You just copy it like this and then copy and then paste wherever you feel like pasting. Then something will like this come on you and click on OK and then you can paste it here. Is it clear?
Yes.
Is it clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Now,
Yes, ma'am.
now you can just, this is just the simple regression analysis from where you can understand how the imports are related to the dependent variable GDP. There is a negative association between imports and GDP. There is a negative impact of imports on the GDP, which is true also as per the theory also. Inflation and then again, inflation and sorry, I'm missing something. Okay, inflation and GDP is positively associated. Unemployment and again GDP is negatively associated. But you'll see this the probabilities values are not less than 0.0 point. Like who is doing this? Please stop doing anything on the screen.
Kindly avoid this. Else I will throw you out of the room.
Okay, you'll see the relationship between import, inflation, and employment is explained. The coefficient is explained. How much change in GDP is there due to change in the import. So that is the relationship explained. Now you'll see the probability value is way more than 0.05. So in that case, this relationship is not significant. Here you may have to find the reason why it is not significant. But if your result is not significant, you'll have to report it like that only. There may be problem with the data set because we are just taking a random data set. It might not be true also. Okay, so that there may be problem with data set. So that is nothing to worry about. Just understand how you interpret that, how import is related negatively with the GDP, but the results are not significant as the p-value is more than 0.05. Similarly, for inflation also, the relationship is not significant. And for unemployment as well, the relationship is not significant. Okay. Now, the main thing is the R square we go for. That is the R square is the value of the R square is the 0.1281. So that explains only 12.8% of variation in GDP. So R is explained by the model, which is not sufficient enough. Okay. Now you'll see the value of the adjusted R square is also very less. It is more weaker than even after adjusting the number of predictors. Then F statistics value, model is not statistically significant. You'll see the F value, the P value is given less than 0.05. It's less than 0.05. Sorry, it's greater than 0.05, this value. So we say it is not statistically significant. Now, this Durbin-Watson statistics we'll discuss when have a problem of the autocorrelation. This is where we check actually autocorrelation is there or not. We'll do it again. Now, this is the output you have. The next thing is to check the heteroscedasticity is present or not. Now, this is the interpretation also given. I'll share this document with you. You will understand how you have to interpret the import with respect to GDP, inflation with respect to GDP. You can get every kind of information from this particular document. Okay. Overall, the model is not explained well by the independent variables we have. Okay. Now, the next is to check the next step is to check the heteroscedasticity. Now go to view, residual diagnostic, and then we have a, sorry, we'll do it here. Go to view, then residual diagnostic, the test of the heteroscedasticity. Here we have various tests. BPG test is the first test given. Then we have a white test also, which are most common test. Two tests are, but all these tests, they produce similar kind of results. So you choose BP test, the first test, and then click on OK. Done?
Yes, ma'am.
Okay. Now, copy and paste this output on a paper and how you will be interpreting it. This is how you will be interpreting it. Now, the probability value of the F statistics. Now, this is the only F statistics we are concerned about. That is the first value, F statistics value and its probability value. We'll be checking if you want to check heteroscedasticity is present or not. Now, you see the probability value is more than 0.05. So we fail to reject the null hypothesis. So what was the null hypothesis? There is no heteroscedasticity. There is no heteroscedasticity. So we fail to reject the null hypothesis. It means there is no heteroscedasticity present in this particular model. So we need not to worry about the OLS estimates are the best estimates in that case. Okay. Yes, clear?
Yes, ma'am.
Okay, so you'll see we can check the F statistics probability value also. We can check the observed R square value also, that is greater than 0.05. In any case, F statistics value or observed R square P value is greater than 0.05. We cannot reject the null hypothesis. We have to accept the null hypothesis and reject the alternative hypothesis. So that's how you interpret also. We fail to reject the null hypothesis and accept the alternative hypothesis and conclude that there is no problem of the heteroscedasticity present in the model. Clear? Is it clear so far?
Ma'am, can you repeat once more?
The process or just the explanation part?
Just the explanation part.
Okay, so in that case, when you are running this BPG test, you are just concerned with the F statistics and observed R square value. The more priority is given to the F statistics value with respect to the probability value given. When you say the F statistics with the given probability value is greater than 0.05, that is the assumed probability we are assuming, where we are rejecting the hypothesis or accepting the hypothesis. We reject or accept the hypothesis at different confidence level. That is the 1%, 5% and 10%. Here we are accepting or rejecting the null or the alternative on the basis of 5% level only. So you'll see F is the F statistic probability value is 0.80, which is greater than 0.05. So we fail to reject the null hypothesis and we say there is no problem of the heteroscedasticity. Is that okay?
Yes, ma'am. Thank you, ma'am.
Okay. Now, if this problem is there, now what to do? Okay. Now, if this problem is there, suppose this problem is there, though we don't have any problem like this in our model. If this problem is there, now what to do? Now, what you do on the same output, click on estimates, and you will get your the previous slide where you have mentioned your regression equation. Now, what you have to do, you just have to take a log of your variable. That is the first method we choose when there is a problem of the heteroscedasticity. Okay. If you take the log of the data, the variability in this data set, it can be reduced, and there a normality can also be achieved. There are a lot of problems related to the data set. If you take the log of those data set, you can actually improve on that. Okay. Now, what you do if there is a problem of heteroscedasticity, you will just put log here only. You need not to go back to your Excel sheet. So just write log and keep your variable in the bracket. Okay. Don't use the capital words. Log and then bracket close. There should be no space in between. Okay. When you're doing it, then again log bracket for import. Then again for inflation also log, then put it in bracket close, and then for unemployment also log, and then put it in the bracket and then close the bracket for unemployment also. And then you'll see we need not to do it for the constant C. Then click on OK. Click on OK. Now, this is again the output which you have to interpret in the same way as you did the first regression output. You'll see this is how we have done it. Again, explain it the same way. And again, explain it in the same way as you did the earlier one. Check the heteroscedasticity problem again. Go to residual diagnostic, heteroscedasticity test, BP test, and then click on OK. Okay. Now, check the value of the F statistics again and the P value associated with that. Okay. Now, you'll see it has increased than the previous values. What were the previous values? Yes, the previous value was 0.80. So this is 81 now. The earlier was 0.77. So it is 78 now. Because the problem was not actually there. So it has not changed the results as much. But this is how your P value for the F statistics will change. And even for the observed R square, your P value will change. And then you will realize that there is no problem of heteroscedasticity anymore. Okay, this is one way to remove the heteroscedasticity. Is it clear so far?
Ma'am?
Yes.
Ma'am, this log what we are adding in this software, this is only
Yes.
to have a better understanding or to have a better value?
No, it's not for better value. It is to solve the problem of the heteroscedasticity.
Okay, ma'am. Okay, so if in case we are unable to work on, so we will be putting log for it and we are going to try again.
Yes.
Is this going to? Okay, ma'am.
Yes. Yes. You have to again run the regression and you have to check it again, and then you have to check whether this P value has increased, goes up or not. It is going up or not after taking the log or not. because in this data set there was no problem of the heteroscedasticity, so that's why we can't change much, we can't see much changes in the result. But if actual problem is there, you'll see a difference in probability value in the previous regression output and in this output.
Okay, ma'am. Thank you.
Okay.
Ma'am, just one more,
And-
sorry to interrupt.
Yes,
Actually, in
yes.
future, if we find some error in our data set, so it means we
Mhm.
have to recheck with our datas and try to work on it.
No, what sort of error you are assuming?
Like for example, ma'am, in your data set, there was no issue of
Ah,
heteroscedasticity. So in case in my
exactly.
data set, yes, if in my data set we found that even though I'm using log, I'm unable
Hmm.
to get the proper value.
Hmm.
So in that situation, should I recheck or redo
Then
my data set?
yes.
Okay.
Yes, yes. In that case, you may have to drop one variable, or you may have to find a particular variable which is causing more problem in your regression equation. So that's what we do. We done the equation. Suppose in the first time you are adding all the four independent variables and you're checking your result. In the second time, you can drop one variable and try to run it again. Okay, and then in the third time you can drop one more variable and do it again. So sometime one particular variable, one particular series may be causing a problem in the model, or there can be, a problem with overall model, overall data set. So you may have to check the data set before.
Thank you, ma'am. Thank you so much.
Okay, now the next method is we can check this problem of heteroscedasticity through the graph also. No, uh, what we can do, we can go to view, and then we can check actual fitted residual graph. Okay, now this is the graph. This is the graph. Now, this blue line is the residual term, your error term. This blue line is your error term. Your red line is the actual GDP, and this green line is your estimated GDP. This is your estimated value. Then you will see the actual GDP and the estimated value are more or less close to each other. No, but your error term is somewhere going beyond control after this 15, or somewhere around 15, and it is very volatile, just showing somewhere there can be a problem of heteroscedasticity. But our result of the BP test says confirm that there is no problem of heteroscedasticity. So if you just don't want to run anything, you can just check from the graph also whether this problem is actually there or not. You can copy it and paste it in your output again.
Excuse me, ma'am.
Yes, sir.
Yeah, ma'am. How would the graph look like if there is a problem of heteroscedasticity?
Then this residual term will be highly fluctuating, and you'll find a difference between your actual and estimated output also, estimated and output GDP also.
Okay, okay. Thank you.
Okay, there will be fluctuation, a lot of fluctuation in the graph itself. Okay.
Okay.
Yes, I think that's two method we can use to detect the heteroscedasticity. Okay. Now, what are the remedies for the heteroscedasticity? Log transformation one we are using. The other method is you have to change your analysis model. You have to change your model. That is, you can't use the OLS method. There you have to use the GLS method, that is generalized least square method, which allow the heteroscedasticity to be there and then gives you appropriate result. One more thing you can do is, instead of taking log, if we go to the previous model, okay, I'll go to the first model. I'll do it again. Just give me a second. open as equation. And then, okay, now we don't have logs. You can go to option. You can change your option here and you can use Hack-Newey-West test. Okay. This is also one of the method to remove heteroscedasticity from your model. And you'll see the output will change here, the R square will change here, everything will change. You will find a different kind of a results. You'll see R square is still 12.8% as earlier. Still the model is explaining very less. One second. Just have to. Thank you. It's not on yet. It's not on. One second. There is problem with my battery. I have to fix it. Okay. Okay. So, am I audible?
Yes, ma'am.
Yes, ma'am, you're
Okay.
audible.
Okay, so if you'll see, still the results are more or less similar. The R square is still 12.8. But in case there is a problem of the heteroscedasticity, then these results will definitely change. The only thing is when you are estimating it, you have to change the option of Hack-Newey-West test. So this also consider heteroscedasticity, remove that problem and then give you valid result, which excludes the problem of the heteroscedasticity. So we have three different methods. One is through the graph. You can check whether heteroscedasticity is there or not. To solve it, we can apply the log. And the third one is we can check we can use the Newey-Wack hack test. And if you really want to change the model and you want to go with the same model, then GLS is the appropriate model. Then you can't use the OLS in that case. Is it clear so far?
Yes, ma'am.
Hey, if we have any question, we can ask now, please. Okay, let's go with the next one. Then that is the problem of the autocorrelation. Okay, now you just close all the tabs.
Hello.
Yes.
Hello.
Yes.
Madam, here is it data is real data?
This is a data set I had, like previously we were using it for the one or the other experiment. That's what I'm saying. If you do it on your data set, the results may be different. You have to check it. I have told you the way how you can check it. Okay. And you'll see in most of the data, heteroscedasticity is not there. In like only few of the data set, this problem is there. So you will have to check whether you on your data it is there or not.
Another is there is covariance. Please back it.
There is.
I saw somewhere covariance. What is this represented?
Here in this
What
slide?
represented covariance?
No, in this slide you are talking about?
No, ma'am.
Where you read covariance?
I have seen, ma'am, just
covariance is basically how covariance is basically it explains how two variables change in particular direction. How if I say with my increase in income, consumption is also changing. So that is like covariance. There is a covariance between those variables and they are moving into same direction in that case. So that is covariance. It actually explains the relationship between two variables. Basically the direction of the relationship.
Suppose covariance value is negative minus 1 point, suppose 1.4. 0.4. So what we conclude that with the help of that covariance value?
What is covariance? Minus
1.4. What we conclude it?
Okay, so
So it
no, sir,
means,
then you can say there is a, yes, sir.
please go ahead, please go ahead. I'm sorry.
Okay. Okay, so we'll be doing autocorrelation first, and then in the end, we'll be taking the questions also, because we still have to do autocorrelation and multicollinearity also. Okay, so now with the same data set, we'll be checking the autocorrelation. The process is same. You just have to click on the variables. First is the dependent variable, then independent variable, and then open as equation, and then use ordinary, and then click on OK. Now this is the output you have. Okay, this is the regression output, which is explaining the relationship between the dependent and the independent variables. Now you want to check whether autocorrelation exists or not. The first criteria to do that is the doing it through the graph. Okay, now how you do it? Go to view, go to actual fitted residuals, and then graph. Sorry, go to view, then residual diagnostic, then serial LM correlation test. Keep the lags to, one second. One second, I'm doing it. This is residual graph. Wait. No, this is not there. Go to residual diagnostic. Okay, so this is the one. You have to go to view, residual diagnostic, then you have to go to this correlogram Q statistics. Okay, the lags are mentioned 12. Just keep the lags like that and click on OK, and you will get a graph like this. Now, here the value of AC is autocorrelation, and PAC is the partial autocorrelation, and then the probability is attached with each kind of a autocorrelation. Now, how you read it, how you explain this graph. This is how you interpret it. Now, AC is autocorrelation at each lag, partial autocorrelation at each lag. This is the Q stat is the Q stat test joining significance of autocorrelation to that lag, like for each lag. Now, probability tell whether autocorrelation is statistically significant or not. Now, if you see, all the probabilities values are more than 0.05. So there is no problem of the autocorrelation. Through this graph, we can say there is no problem of the autocorrelation. Okay. Similarly, if you see at lag 1, p value is 0.41. Okay. This is at lag 1, the value is 0.41. This probability value 0.41. Now at lag 6 is probability value is 8.14. Okay, and at lag 12 is 0.796. Now, which all the lag values are above 0.05. From this graph, we can say that there is no problem of the autocorrelation. And there is one more method to check it. If you'll see that these lines are within these lines, autocorrelation, there are two lines drawn, and all the autocorrelation moment is within these two lines. If you see any of the graph is coming beyond this line, then there will be a problem of the autocorrelation. That is the other way. If you just want to check autocorrelation, just having look at that particular graph instead of p values, If all these lines are within these two lines, then there is no problem of the autocorrelation, whether it is autocorrelation or whether it is the partial autocorrelation. Okay, that is one method to detect the autocorrelation. Now, the next method is DW statistics of your regression equation. Click again on the estimates. Click again on the regression. Okay. Now, your DW statistic is 1.68. Now, there is a criteria. If your D statistics value is less than 2, is equal to 2, then there is no problem of the autocorrelation. If it is more than 2, then there is a positive autocorrelation. Means if your past value is predicting the current value in a positive way, there is a positive association between that. Then if it is greater than 2, then there is a negative autocorrelation. And if it is equal to 0, there is extreme positive autocorrelation, and equal to 4, extreme negative autocorrelation. There is no problem as long as it is between 0 to 2 or close to 2. There is no problem of the autocorrelation. If the values goes beyond that, then there is a problem of the autocorrelation. It can be negative also, it can be positive also. Okay. So this is how you interpret. Now this is how you interpret. You check your DW statistics is equal to 2 or no autocorrelation, greater than 2, less than 2, positive autocorrelation, greater than 2, negative autocorrelation, is equal to 0, extreme positive autocorrelation, and equal to 4, extreme negative autocorrelation. Okay. Now the third method is we check it through the BP test. Okay. Again, click on this. Output is there. Click on view, residual diagnostic, then serial correlation of LM test of serial correlation, keep the lag 2. Now, why to keep the lag 2? In most of the cases, the number of lags is more than 2, or it can be more than 4 also. But when we are working on economic data, it is suggested to keep the lag up to 2 only. Otherwise, it will reduce the, the nature of the data, or it will reduce the quality of the data set. We can't include so many lags in the data. Okay. Now click on OK, and you will get this kind of a result. Now, if you'll see, the value here is less than 0.0, sorry, it's greater than 0.05, then there is a problem of the autocorrelation. So, within this, the problem of autocorrelation exists. Okay. The F statistics, you will check the F statistics, you will check the probability. The probability value is greater than 0.05, means there is no problem of the autocorrelation. Sorry, in this data set, there is no problem of the autocorrelation. If this value, the probability of the F statistic is less than 0.05, then only there is a problem of the autocorrelation. But in this data, there is no problem of the autocorrelation. Yes, is it clear so far?
Ma'am, can you explain what does lag mean?
Lag means suppose you are working on a GDP data. Now GDP of present is dependent on the GDP of the past. So when we say GDP is dependent on the GDP of the past, we take it as a -1. So that is the lag. Lag takes you like one period. Before the data set you are taking. Suppose you are working on the data set of 2000. So you will choose the data set of 1 year before that. So that is the lag. We introduce lag in the data set to deal with this problem of the autocorrelation.
Okay.
Okay.
Excuse
We
me,
don't do
ma'am.
it manually, but in the system only we can do it. Yes.
Ma'am, yeah, is there is any range between taking the lag value, or
Yeah, that's
we can
no.
take any number according to the data set?
No, we can't take any number of lags. If you will study theory always suggests that in case of economic indicators, 2 lags are more than sufficient, because taking too many lags you will lose the actual value. What is the actual value for today? You are compromising on that particular value. So you can't introduce too many lags. 2 is sufficient or 3 is more than sufficient. That's enough. That's what we do. We don't go beyond that.
Okay, ma'am. Thank you. Thank you.
So we have 3 different methods to check the problem of the autocorrelation. The first one is the correlogram. The second one is the DW statistics. And the third one is the BP test. Okay. Now, what to do if this problem is there? Remedies, what you can do? Again, click on estimates. Again, the same method is there to deal with this also. You can take hack new EViews test and you can click on OK. Now again, you can check where the LM test, residual diagnostic, serial correlation LM test, and then you will see this value will change. If this problem is actually there in the previous model, then you will see a huge difference, in this probability value, because we don't have this problem in this particular data set, so we can't see much changes. But in case there is a problem, you will see the probability will become greater than 0.05 if it is not previously. Then we can say that now there is no problem of the autocorrelation in the data set. Okay, then second is the second option. Now, how to correct it? This is the first option to choosing the hack new EViews test. Now, the second option, what we can do, click on this, keep it ordinary, and then click on OK. We have this output. We can introduce lagged of the dependent variable. That is what we do in case we are dealing with the problem of the autocorrelation. We are supposed to choose those variables, those models where the dependent variable is independent variable also in the model with a lagged variable. Now what we do for that case, you have to
Sorry for
click on
inconvenience, ma'am.
estimates.
Excuse me,
Yes,
are
sir.
you getting? Please go a bit slow. Participants are not, picking up. You just try to
Okay.
make it slow, or whatever, you are showing, try to repeat it so
Okay,
that
sir.
they can
Okay.
follow up with you. Thank you very much.
Okay, sir. Okay. Now this autocorrelation, everybody know how to detect it. How to check it, whether it is there or not. Now to detect it, what we can do, we had this equation with us. From here, the first thing we can do is the clicking on hack new EViews test and click on OK. In the first, we checked the model. This was the original output. But now we want to check whether after applying hack new EViews test, there is a difference in the residual or not. For that, we have to go to view, check the residual diagnostic, and then check the serial LM test, that is the correlation test, and then check the value of the F statistics. You will see if there is a problem of the autocorrelation, F statistics will have a probability value less than 0.05. But in this model, the F statistic value, the probability is more than 0.05. So there is no problem of the autocorrelation. And there is, even after applying the hack test, there is not much change in the probability value of the X statistics. But if actually this problem is there, you will see the difference between the p-value of the F statistics before applying that hack test or after applying that hack test. Okay, is it clear? The first method is clear? Yes, any participants can reply. Is the first method clear?
Yes, ma'am, clear.
Okay.
Yes,
Now,
ma'am. It's
what is
clear now.
okay? Now, the second method is whenever we are dealing with this problem of the autocorrelation, you will see we are taking lags of the dependent variable. We have to add those lags of the dependent variable in the model. Then how we do it? Click on click on estimates, keep the model ordinary only. Okay, so that we can understand the results even after adding the lagged value. Now what you do, you just add the lag of the dependent variable. Okay. That is the GDP. Here we'll add GDP minus 1. Okay, this is what you will be doing. Okay, I'll show you how you have to write the equation. I'll show you here. This is how you have to write GDP in bracket minus 1. Okay, then click on OK. One second. Now you'll have one new variable, that is the GDP minus 1 also with you. Okay, and this is the result you have to interpret after adding the lag as the minus 1 also. Sorry, there is some mistake. Okay, wait, there is some problem. Now, these are the results you will get after adding the lagged variable of dependent variable, and you will be interpreting these results. Now, again, you will be checking the results, whether these are okay or not. You will be interpreting these results. Now, you'll see the value of the Durbin-Watson statistic is 0.2, means there is no problem of the autocorrelation. After doing all these things, you just have to check the value of the DW statistics, and you just explain all these points, and you will see after adding the lag, the value of the Durbin-Watson statistics is different as compared to the previous one. Previously, it was 1 point something, and now it is 2 point something. So you'll see there is a difference in the DW statistics. So there is no problem of the autocorrelation now. Is it clear?
Excuse
you
me,
can,
my results are coming a little different from yours. It's my lagged value of GDP is coming around 0.840108, and my Durbin-Watson statistics is coming around 2.692111.
You see, this is how you have to add the GDP, and there should not be any space when you are putting a bracket and minus 1.
All right. Okay. No, there's no space.
Okay.
I've done the same thing as yours. Okay, my C component was missing.
Yes.
Okay. Thank you.
And will there be no space before C?
No, you can add that also. Even that is not a problem. C is not a problem. You just have to make sure that the. Okay, 1 second.
No, it's fine now. Actually, the C was missing. Thank you.
No, you can add space in the C also. Then also you'll be getting the same results.
My C was only missing actually. C gayab tha wahan
Okay.
se. Okay, thank you.
Now is it okay?
It's fine now. Thank you. The results are
Okay.
same.
So, how you can understand which test to use when you are doing this autocorrelation test? DW statistics is, DW test is applicable when you are running a simple regression, or when there is only a first order autocorrelation, the autocorrelation is not very high. Okay, BP test we rely on when there is a high order autocorrelation, or we are using multiple regression, we have multiple dependent variables, independent variables. In that case only we are using the BP test. Correlogram we use for in any case, like just for the visual representation of your data set only. And the EViews test also, it's a robust estimation you can use with the any kind of autocorrelation is existing. So that's how we deal with the autocorrelation. So we are done with the autocorrelation also. Now we'll do the multicollinearity part also. Okay. Now I am willing that all of you should do the regression part at least yourself. Do it yourself and then let me know whether you are able to do it or not. And then we will do the autocorrelation part. Is it okay? I'm not getting any answer. Am I audible?
Yes. The regression part is already done, ma'am.
Okay. So we'll go for GDP. We'll go for import, inflation, and unemployment again. And then click on open as equation. And then again, this is there. Okay. Now we want to check the problem of the multicollinearity. We go to view. We go to coefficient diagnostic. Then variance inflated factor. Okay. So this is the variance inflated factor. Okay. Now again, I'm telling, we go to view if we have output. This is the output, regression output we have. We go to view, we go to residual diagnostic, sorry, coefficient diagnostic, and then we check on variance inflation factor. That is the VIF. And this is the output we have for VIF. Now, how to explain the VIF? If VIF value is greater than 10, then there is a problem of the multicollinearity. If the VIF value is between 5 and 10, there is a moderate concern, that is not a big problem. And then if VI is less than 5, it is acceptable, there is a problem of the multicollinearity. Okay. Now you check your results whether there is a multicollinearity or not. Now this is the value of the VIF. So you'll see all the VIF values are less than 10. It is less than 10, even it is less than, it is less than 5. So there is a no problem of the multicollinearity. Okay. For import, there is no multicollinearity. For inflation, it is 1.89, still low multicollinearity. And for unemployment, it is a moderate, but still not alarming. So in this model, there is no problem of the multicollinearity. Okay. So all the VIF are less than 5. So there is no problem of the multicollinearity. Now, what happened if the multicollinearity is there? There is only one method to check whether the problem of multicollinearity exists or not. Now, this multicollinearity is not a problem when we are running any analysis on the cross-section data. This is related to only time series data set, and this is only related to the panel data. This is not a problem with the cross-sectional data. Okay. When you are working on the cross-section data, you need not to check even the multicollinearity properties over there. You just have to check in case it is a time series data. You have to check when it is a panel kind of a data set. So there is no problem of the multicollinearity. If it is there, now what to do? There is no method we can apply directly here. Only what we can do, we can drop one variable. You have to check which is the variable which is causing multicollinearity. What you do again in that case, when you are estimating equation, you will drop one variable, unemployment. Suppose I'm dropping one variable from the equation, and then run it. Then again check whether multicollinearity exists or not. Again, you will check for the VIF. Okay. Again, in this case, though there is no multicollinearity, so results will not change. But in case multicollinearity is there, your VI value will change. It will become less than 5 if it is there is no multicollinearity. If it is more than 5 or more than 10, there is a multicollinearity. But after doing this, dropping one variable, if there is a change in the VIF value, so that particular variable is creating a problem of multicollinearity in your model. You have to either change that variable, take another proxy variable, or eliminate that variable directly from your equation. That is one way we can do. Or most of the time this problem exists in case we have a large number of variables which are similar in nature, especially when you are working on the primary data. Even in the secondary data, if you say I am adding my permanent income also, I am adding my monthly income also, and then I'm adding my wealth also, so somewhere they are similar to each other. So in that case, you will have to find which variable are similar to each other and which particular variable I can drop. And that is something where you can do from the factor analysis also, from the principal component analysis also, and then creating a correlation matrix also. Okay, those are the different kind of techniques you can apply to check whether there is a high correlation between two variables. You can drop one variable from that, and then you can redo the analysis part with new variables in your model. So the only safest way to understand which variable to include in the model and which to not is there is only one way. That is the go to the theories, go through the theories in detail. Whatever theory is explaining, just try to work on those models only, existing models only. If you want to add any new variable into your model, you have to make sure that theory is supporting that this is actually a valid variable to study that particular relationship. So that's all I think from my side. Okay. Now questions can be asked.
Ma'am, I have one question. Now,
Yes.
previously, when you were running auto regression, you just added GDP -1 in the model. Here, you are
Yes.
deducting with unemployment. Is that looking at the results that decision comes in?
No. I am just telling you that this is the way you can deduct any particular variable. Earlier, that was not for the autocorrelation. This exercise is just done for the autocorrelation part only.
Okay. Ma'am,
Sorry,
now-
this exercise is done for multicollinearity only.
Yes.
Yes.
Ma'am, you said that if in case you want to check, if you're not getting that value, you can put -1 for unemployment.
No. We can't do so. I mean, like here we are checking multicollinearity. That is something we do in case there is an autocorrelation. Autocorrelation is entirely a different scenario. Autocorrelation is when one variable is related to its past value. So that is the problem of the autocorrelation.
Okay.
There we use the lagged value of dependent variable in that particular model.
So in that case, any of the dependent variables we can use the lag, ma'am?
We have only one dependent variable.
No, ma'am. In general, I'm asking.
Yes, you can do it for, suppose you're working on stock market data set. It's usually related to its past value. Stocks are related to its past value. Inflation is related to its past value. Then we have, inflation is there, stocks are there, rate of interest is there. There are so many things which are related to its past value. If you are studying something like that, you are supposed to get a problem of this autocorrelation. In that case, you will have to adopt with different methodology, not the OLS, or still you want to use the OLS, then you have to make sure that you use the lag of the dependent variable.
Okay, ma'am. Thank you.
Excuse me, ma'am. Will you be sharing this Word file with us?
I'll share it with Firdaus sir, and he can actually communicate with you.
Okay, ma'am. And I have a very silly technical question. The while when you were selecting those variables, now like GDP, imports, and inflation, I am asking a very silly technical question.
That's okay.
Do we have to just click on shift and then press on those variables that we are choosing, or because when I try to do the residual was coming and then I had to go to the box, delete it on manually, and then I could go and do the estimate.
No, you just do one thing, just click on GDP and then
Yeah.
click on control, and then
Yeah.
whichever variable you want to add as an
Okay.
independent variable, then you just click on that and then
Okay.
click on write and then open as
Okay.
equation.
Okay. That much I got, ma'am. Thank you so much. And yeah,
Okay.
and one very basic question is that when you talked about you have to revisit and research the theories, existing theories, just to figure it out
Yes.
which variables and how to go about it, right? Dropping a variable
Yes.
or adding or lag values or whatsoever. So in case there are no, if we want to come up with a theory of our own, right? I know
Hmm.
it's very like we are not um, uh, we are not economist. From an economist point of view I'm asking. So in that case, when there are no existing theories, how do we come up with such if you want, if you have a new theory, noble theory on your own, when you do not have any literature as such, so how do you handle that kind of analysis if you want to come up?
In that case, we don't do the analytical kind of studies. If you want to launch something new, that will be a kind of either discovery or an invention. Okay, and for that also you have to collect the primary data, you have to collect evidences to support your viewpoint, then only you will be applying it to the real world. So that's why we say whenever we are doing any research paper or any thesis or any kind of a research, you or go through the existing theories, try to find a gap over there, and just to fill that gap only you are trying to conduct a new research or new research paper. If you are just saying that okay, to study the consumer perception, I am adding something new which is not been done by the earlier study, you have to prove it whether you are doing it or right or not. You just have to, still you just have to give a theoretical support for that.
All right, because I was asking from my from an economic point of view. My sister, she's from journalism and mass communication, so she was asking me this question. So I've asked this to many professors. So
No,
okay,
it is actually difficult to bring something new.
yeah, I understand.
If you are doing it, you have to prove the novelty. Like you will, it will be
Hmm.
challenging for sure. It's not
Okay,
like you won't be able to do it, but it's going to be very challenging.
yeah, thank you.
Let me add one line here. It is actually one of the important questions she has asked. To develop something new, therefore, one should have some knowledge, right? For example, you are developing, as ma'am has quoted, something on consumer behavior and all. So, therefore, you have gone through the existing literature. That existing literature has helped you to develop something new. So, in research, unless and until you are not supporting your argument, you will do at the end what is the contribution of the research. So you have to contribute something new. So every researcher, whether they are publishing research papers, whether they are doing any research experiment, they are contributing new already, but their contribution is only valid once they are showing supportive literature, supportive methodology and all. So therefore, every researcher is designing something new. If we talk about medical sciences, they have developed coronavirus vaccine, and they have done so many trials. So they have followed certain literature. That literature is helping them to develop something new. So literature in the concerned subject is very important. That is what is helping us to think differently. So yes, you have to defend your findings. Again, you have to have some proxy literature, proxy methodology. And all. So
Yeah,
I
I
hope I have
completely
answered.
agree with you, sir. But then I was told when I was writing an article, so I was told by my supervisor that you can't write anything which is not published. So you have to write only those, include those citations which is published. Otherwise, you can't put that thing.
No, I think he is having confusion. I have published many things, so maybe you have to update your knowledge. What is research? If we check the word re and search, so we are gaining something from previous literature. Then definitely you can develop something. You can develop of your own model. But to reach that model, to contribute that model in the form of publication, there should be background. There should be way why you have reached to that point. Because finally, if you are showing any model, any you have developed any experiment, so you have reached that point 10, but you have followed point 9. You have supposed to follow point 9. You have read many research papers. You have understand their objectives, their methodology, and then only you are contributing something new. That is your own.
Yes, sir. There will be like
You can
research
do it.
gap, right, in the previous review of literature. So that research gap we can fill it like by our own by doing some research. So
No,
that's what.
one is research gap. By research gap, you are able to identify research objectives. You are doing hypothesis testing and all. But if you are contributing something in the form of model, something in the form of theory, uh, just like I will give you my selfish example. I have developed one model. It has been published by Superior. So in that model, I try to focus why the poverty elevation programs in India are failing. So I have published it by my own model. There is also Professor Tareka, co-author in that. I have published it. But to reach that, I have given lot of evidence that why are they are lacking and how my model is different. What things. So research gap is something different. You are making trial, you are analyzing things, but what you are contributing at the end as a product. So that is your contribution that you can only showcase by showing the background. You have to you have to take people to that point. So okay, let us focus on this discussion only. Please go ahead, madam.
Yes, sir. So yes, actually, sir is right. I mean, you can do something new also, provided that you have to support your argument, that you can do with the theory also, that you can do with your analysis also. Suppose that you can do with the primary studies also. That yes, actually, people are saying it. If I say consumption is function of income, that is the existing theory. If I say no, consumption is not a function of income, it is a function of the wealth or parental income, you can actually prove it. Yeah, but you have to conduct a survey on that, and you have to say that okay, I conducted a survey on 1,000 people and they are proving it right. So that is something you can publish it. But you can publish it also, but you can't say something all of a sudden on your own which is not even existing in the system, or which is not even existing in the theory. So yes, you can do something new, and that is only research. So Firdausa, is there any other question from the students?
Uh, Dear participants, if you have any questions, you can start with your questions, please.
Ma'am, can you just share the Word file with us?
Yes, I'll share the word file for sure. I just discussed this autocorrelation, multicollinearity, and heteroscedasticity because these are the three main properties which you have to we don't directly report the results, but you have to check for sure before you apply any kind of a model, whether OLS, whether ARDL, whether co-integration on any kind of a model, causality or something. You have to report the results of these variables. And then one more kind of analysis we do it, unit root analysis. I think you will be doing it tomorrow in the next day lecture. Sir, are we covering unit root tomorrow?
Hello, yes. From tomorrow, now we
Okay.
are going to have, applied econometrics, where you will be enjoying only if you have followed those, sessions well.
Yes.
From tomorrow,
Yeah,
there will be,
because
yes, please.
yes. If you don't understand these properties now, tomorrow you are going to do unit root analysis and then you will be doing some panel data analysis also. But these properties are applicable on every kind of a test, and you have to report the results of these tests when you are publishing paper in a good journal. They'll ask you to submit your data also, submit your analysis also, results also, even if you don't mention in the paper, research paper. So just do give a hand-on practice to these kind of analysis. Any other question?
Good evening, ma'am. Thank you for the wonderful session. I just had a query regarding the fact that if there is an error which occurs due to the changing of the variables between the independent as well as dependent variable, what can be done further to correct that error in cases of such situations? Thank you so much, ma'am.
See, Vartika, error will only be there if your functional form is incorrect when you are estimating any equation, or your data is not there. See, if I click on import, my data set is already there. You can see the value. So if there is no value, still import is there, but there is no value, then also you will not be able to get the output. So before you run any sort of analysis, you just check it individually, all the series, open all the series and check whether data is there or not, whether the form of that data is correct or not, is it exactly similar to the Excel sheet or not. And then there will be no, I think there will be no problem when you are running it, any regression on that kind of a data set.
All right, ma'am. Thank you so much.
Okay, welcome.
Do we have more questions from any participant?
I think they are, yes. Ma'am, you can stop sharing and we can take questions. And meanwhile, I would like other participants to stop on their camera. Please go ahead with your question.
Madam, I have a doubt regarding, as we know, as you said, there are 7 conditions for OLS. So if these conditions are not satisfied, which method we have to use? For example, whether GLS or WLS or a FE model or RE model, or what are the conditions, or how to select that?
Okay. So this, OLS, whenever OLS assumptions are violated, we have to use another models for sure. Generalized least square is there when there is a problem of the autocorrelation. You use the GLS model or the WLS model also. In case you are using the lagged variable as your independent variable, then you use the ARDL model, because in ARDL model, stationarity is not a problem. That is already solved. It deals with the stationarity also, non-stationarity of the data also, which you are covering tomorrow. And it deals with the lag dependent variable also. So ARDL is better in that case. And fixed effect model, FE and REM, you're asking me, fixed effect model and random effect model, we only check when our data is already stationary. So the first step, whenever you're choosing any model, is to check the unit root, do the unit root analysis, check the stationarity of the data set, whether data is stationary or not. If data is stationary, different kinds of tests are there. If data is not stationary, then different sets of tools are there. In case data is not stationary, we go for co-integration. Okay, then we go for causality also. Those kind of a test we can apply. If data is already stationary, in that case, you use the OLS method or you use the FEM and REM method. And then again, FEM and REM we only apply, when there is a, when we say, okay, this the effect in the model is we are not sure whether it is coming from the I or it is coming from the T, whether it is coming through the cross section or it is coming through the time. So, I mean, you just have to study thoroughly before you apply any particular technique. You have to understand the background, and then only you can decide, okay, whether this methodology is there or that methodology is there. For the simplest part, what we used to do when we were researchers also, we used to study the papers, research papers, a lot of research papers. Then we used to understand, okay, what sort of data they have worked on, and just try to, download the similar kind of a data set and try to run the same kind of analysis just to get the knowledge of that kind of a technique. And then we had an idea, okay, this is appropriate on time series, this is appropriate on cross section, and this is appropriate for the panel data set.
Okay, thank you.
And can you set up your screen?
Hello, ma'am. Dr. Deepika here. As you said,
Okay.
maximum leg length should be 2.
Yes.
And ma'am, what about in case if we have seasonal or monthly data?
No, in seasonal or monthly data, usually, what we do there, that we don't take lag for that particular thing, because data is very, kind of, there is a lot of fluctuation in the data. So even in that case, 1 or 2 lag will not be appropriate. So there you will have to check it again and again, using 2 lag first, check the model, then 3 lag, then check the model, then 4 lag, then check the model. So this is how you actually choose the appropriate lag length. And then we have AIC and SIC criteria also to check the lag length. Those you can apply those criterias also and check the value of the AIC and SIC, and then you can apply understand how many lags are appropriate for that particular model. If I apply ARDL model, suppose, and I have to select the lag length, so for that, first of all, I apply the VAR model. From VAR, I will select the lag length, and that lag length I'll be putting in the ARDL model. So those are the techniques you can use. Still, you're not getting into the point. You can just put the lag and then run the model, check the, whether model is correct or not. If not, then add more lag and then redo again. For that exercise, we usually opt for the VAR model. So that is the appropriate way to do it.
Thank you.
Okay.
So yes, we are going to conclude the session. So I would like to request ma'am, please set up the screen sharing so that we can capture a group photo. Are you able to follow me, ma'am?
Yes, I request all the participants to switch on your cameras if you're comfortable so that we can have a group photo.
For having group photo, ma'am has to set up sharing. Hello. Ma'am, are you with us?
Firdous sir, I'm here only. Can you see me?
You have to set up your sharing. You are still sharing your desktop.
Okay.
Yes.
Done?
Yeah. Yes, our participants are ready. Thank you very much. So let us take 1 minute to have your photo. Our participants are good, but they are having only one bad feature. They are not supporting us on our social media. So I have captured the photograph. There is only one frame. So thank you very much. Shivangi, you can conclude the session.
Thank you so much, sir.
I think
Ma'am,
your
it was an
network is not.
amazing session, and on behalf of the organizing team and all the participants of our... So am I audible?
Yes, please go ahead.
Okay. So, Dr. Harwinder ma'am, on behalf of the organizing team and all the participants of our 7-day online workshop, I extend our heartfelt thanks to you for your insightful and engaging session on Introduction to Research Methodology and Econometrics. Your expertise, clarity of thought, and the depth of knowledge you shared have provided our participants with a strong foundation and sparked meaningful academic curiosity. The way you explain complex concepts with such simplicity and real-world relevance truly enriched the learning experience for everyone involved. Your contribution has made a significant impact, and we are truly grateful for your support in making this workshop a success. We hope to have the privilege of learning from you once again in the future. So, dear participants, that's it for today. We hope to see you soon tomorrow on the same time, and we'll have another session with another dignitaries.